Hello. Today we are going to look at nets of shapes, which just means the surfaces of shapes, and the total surface area, or the area of all of the surfaces of a shape added together. And we're going to focus on rectangular solids. So effectively rectangular boxes, like if we had a product in a box, it would usually be a rectangular box. So if I have an example of a rectangular box here and I want to get the net of it, what I can imagine is if it's made of cardboard, we'll say, and we have all of our edges just sealed together. If I cut all of my edges apart and unfolded that cardboard box out into a big flat piece, what would its shape be? Well, I'd have this rectangle on top here. I'd have this rectangle on the front. I'd have the same one. I'd have another rectangle on the bottom. I'd have one behind here where I can't see. I'd have the side that I can see here, and I'd have another side that I can't see back here. So if I unfold those sides, what's it going to look like? Well, look, I'm going to start with the base. So the base that I can imagine is in here. I'm going to draw it in a little bit dashed here. So I have my base of my box that I've got going on here. What would its dimensions be? Well, it's a rectangle, and it's going to have a length of 4 and a width of 2. So the base of my box would have a length of 4 and a width of 2. So I'm going to draw in my base here. It's going to be 4 by 2. Now, what would the front of my box look like? So I'm unfolding my shape now. What would the front of my box look like? Well, it looks like a rectangle with a width of 3 and a length of 4, and it would be sitting along here. So if I had the base effectively coming out of the screen here, if I folded it down towards us here, I would have my length across would be the same, and it would be going edge to edge, the base to the side, and I'm unfolding, and I'd go down 3 this time, and I'd still have a length of 4. So I'm going to keep track of this. This is going to be my base. And if I go up to the top now, I'm going to have another rectangle, and it's going to have a width of 2 and a length of 4. And again, it's going to join to the top part of my front here. And it's going to have my width of 2, my length of 4. So this is my top of my box now. I'll mark that as top. This was my front. And then the back of my box is going to have a width of 3. It's going to have the same width as the front. And still we're folding over again. Into 3, and it's going to have my width of 4. So I've unfolded the main section of this box, but I'm missing a little bit. I have my sides of my box. Now where will I put them? Well, I'll say that I am going to put them on the, as though we had taken them and folded them. So we've cut all of these edges here, and we're going to fold them out so that they're attached at the front. So they're going to go out by 2. They're going to go up the front by 3, and they're going to fold out by 2. And I can put the side here that we can't see clearly out at the same point. And we'd again have 2 and 3, because we know that this length is the same as this length is the same as this length. We can see that by unfolding that shape in our minds. Now, as I was going through that, you may have figured out a different way of unfolding this base. And there are lots of different ways that you can unfold it. Any way that you could take your box and unfold all of the shapes so that you could fold it back together or again into the box is perfectly fine. There are many, many ways of creating the net of any box, and as we go on into more complex shapes, there'll be lots of different ways of doing nets of them as well. So this is a single example of how you could have ended up putting together the sides of our shape, or the net of our shape. So this is the net again of this shape here, and all it is I take all of the surfaces and I fold them down flat. And there are lots of different ways that I could have cut my shape to end up with different looking nets, but they'll all have the same total area. For instance, instead of having the sides fold off from the front of my box, I could have had them folding off from the top of my box, and that would have worked just as well. I would have had length here of 2, and it would have gone out in that case by 3. And you can experiment with different ways that you can create your nets, but all it is looking at the shape and carefully unfolding it so that all of the surfaces are still connected together. And that's our net. Now again, the net allows us to see the surfaces of our shape very easily. We can also just do it from our original 3D sketch if we're comfortable with that, but the net can help with understanding the area of all of our surfaces. And leading into that, we are often asked for the total surface area of a shape, and it just means the area of all the different surfaces added together. And we know how to get the area of each of these surfaces because they're all just rectangles. So what we're looking at is how to get the area of each surface and then add them all up. And we can either use our net to help us with that, or we can get it from the shape directly. So the total surface area, I often call it surface area for SA, would be the area of my base, my front, my top, and the back and the 2 sides all added together. So I'm going to have the area of my base is going to be length by width is going to be 4/2. And the area of my base would be 4/2. The area of my front is going to be 4/3. So I'm just getting the area of each individually and adding it all up. The area of the top is going to be 2/4 or 4/2. The same in this case as the base. And the back of the box is going to be the same as the front. It is going to be 4/3, plus the sides are going to be 3/2, plus 3/2 for the other side. 2 sides are going to be identical because we're dealing with a rectangular solid. So we can multiply all of them out and see what total surface area we get. So when we do all of our adding up, I've gotten the area of each one of the shapes individually, each one of these surfaces individually, I should say, add them all up, and I get 52 in total, and that's meters squared because we're dealing with area. We've multiplied length by width, so we've ended up meters by meters is meters squared, gives us our units, and it's important we include our units. And that is what we need for nets and surface area of rectangular solids.